Hello again. I'm just preparing this video to help you with particularly with your assignments, the first assignment, but also just to give you some general information about open-ended tasks. Mathematics education has got a history of being characterised by very closed tasks. So some of you, when you went to school, might have had the teacher give some teaching, give you a couple of worked examples, and then you'll do lots of exercises from a textbook, and that has its place. And also when you were doing assessments, of which this assignment is asking you to do something, usually it was a test with very specific questions. And indeed some of you might have done things like NAPLAN and things like that, which are all pretty closed sort of questions. Indeed, a lot of diagnostic work in the past has been done with very closed questions. We want to know if they can add up two three-digit numbers, so we simply give them a task, which is to add up two three-digit numbers, and from that we can say, can they do it or not? So it usually looks very much like a test. Now again, that has its place, but I want to encourage you in this assignment to use open-ended tasks, and I'm going to give you an example and I'm going to give you some reasons why. So first of all, if you use open-ended diagnostic tasks, what it does is it gives you an opportunity to access a greater range of abilities in one task. So if you have a closed task, it'll tell you something very specific, like the example I just used before. Can they add three-digit numbers or not? That's all it will tell you. And again, that has its place, but if you use an open-ended task, you're going to be able to access a far greater range of things. And that can be useful, particularly here where you're coming in cold with someone you probably haven't worked with, at least in a teaching sort of role before, and you'll get access to things that about different mathematical things to see what they know and understand. The other thing is an open-ended task helps you under a broader range of things. So not only you'll learn if they can do the mathematical skills or if they have the knowledge, but you'll also understand things like, can they do problem solving? Can they model something? Can they think mathematically? And also you'll find out how they feel about maths, what they're confident with, what are their attitudes like. Because when you're teaching maths, those things are as much a part of the content as the content is. And you want to understand their broader understandings and identity as mathematics learners. So that's why I think open-ended tasks work well. It's a little bit harder for you as a teacher. If you do a closed one, you simply write a question and you get the answer. Whereas here it's going to require you to develop some tasks, not too many, and then work through them and ask them some probing questions to get the answer. Anyway, so here's an example. And I want to show you how simple it is. Don't make it too complicated. My example is, ask the student to draw a rectangle with a perimeter of 24 centimetres. That is the open-ended tasks. And what they will do is then you see if they can draw it. We don't really need them to use a ruler and measure it exactly, as long as they can draw it and label it of what the measurements are. Now hopefully that won't take them too long, particularly because you're dealing with junior secondary students. But it's a start, and from that you'll understand if they do know about rectangles, if they know what a rectangle is, if they understand what perimeter is, if they can understand units of measurement. And you can get that all from that task. So you can see even at that level it's much more open than just what is the perimeter of this rectangle where you draw it and the sides are, say, 8 by 4 or something like that. So I would just give the student this task: draw a rectangle with a perimeter of 24 centimetres. And then after they've done that, the next thing I'd say, is that the only answer? So often they'll draw something, probably an 8 by 4 or something like that. Is that the only answer? And of course it's not the only answer, there's lots of answers. And what you can then see from that is, can they understand that problems have more than one solution? And then if you can see if they can be systematic about trying to find the other solutions. So often what they'll do next is draw another one, and you'll say, okay, you've got two, are there any more? So often, let's say they started with a 10 by 2, then maybe the next one they will do will be an 8 by 4. And then you say again, are there any more? And they might do a 9 by 3 or something like that. And then what I would encourage them to do is say, well, how many are there? How do you know how many there are? And hopefully they'll be systematic about this. So you can see if they can do problem solving, if they can be organised and systematic in investigating something. So hopefully they might draw a T-chart. So instead of just having random ones, they might try and look for a pattern. So if they did a 10 by 2 first and they did an 8 by 4, maybe they're going to see then the 9 by 3. And then they would possibly go, oh, okay, an 11 by 1, and then they might do a 7 by 5. And then we'd ask them, is that all the answers? How do you know if you got them all? And at this point, hopefully some of them will start saying, oh, actually we could do decimal numbers as well. And of course, there's multiple solutions. There's an infinite number of solutions to this. So even from that very simple task and asking a few simple probing questions, you're going to find out, do they know what a rectangle is? Do they know the properties of a rectangle? Do they understand perimeter? Do they understand what 24 centimetres is? Can they investigate something? Can they do problem solving? Can they be systematic? Can they look for patterns? Can they identify patterns? And can they generalise? The next thing is, well, can you see a pattern in the answers? And of course, the answers is the side will be whatever one is, they have to add up to 12. And they may be able to represent that algebraically if they can see the pattern. So from a very simple task, I think you can see there's lots of things you can do. Starting from some mathematics, which is obviously primary school mathematics, and moving on to things that are in the secondary school. Now the beauty of starting with this one too is hopefully all the kids can do the start. They can all start by drawing a rectangle. It's accessible to everyone. It's not like some kids going to look at the very first thing and go, oh, I've got no idea. You're starting with something that's accessible to everyone, and then you're moving on from there. And as you go through, if you get to a point where they really can't do anything, you'd start giving some prompts and hints, and if they're really lost, then you know it's time to stop. Just some other things you might learn from here. If you follow that patterning we were talking about just before, you'll have an 8 by 4, a 7 by 1, and then they'll get to the next one, which will be a 6 by 6. Now this is another opportunity for a really interesting mathematical debate, because obviously a 6 by 6 is a square. And at this point, you've got to say, what shape is that? And they'll say a square usually. And you can say, is that a rectangle? And most kids will say that it's not a rectangle, it's a square. And so then you can understand, do they understand that a square is a special sort of rectangle? A square is a rectangle, but a rectangle is not necessarily a square. And then if they keep following the pattern, the next one would be a 5 by 7. And you can see that then you could ask them, oh, okay, is that another solution? Or is that the same as the 7 by 5? Is it still the same rectangle if it's this way or this way? So again, a whole pile of discussion you can have about mathematics to see if they understand that a rectangle is a rectangle, whether it's drawn sideways or upside down or back to front, it doesn't matter. There is no such thing as an upside down rectangle because a rectangle is not oriented in any particular way. So from that simple task at the beginning, simple open-ended question, hopefully you can already see a lot of mathematics you could do. Now we haven't finished. There's more things you could do here. You could then say, well, which ones of these has the biggest area? Now at this point, some of them might be already out of their depth and you can just stop, but a lot of them will still be able to go. And at this point then you can understand, oh, well, do they understand the area of a rectangle? Can they work it out? So if their first one was 10 by 2, do they understand that the area is 20? And then you could say, well, which one has the biggest area? And some kids at this stage will say, well, they've all got the same area because it's the same perimeter. And then you'll find out when you get them to calculate a few of them that the area is not the same for a fixed perimeter. So again, if they've been systematic and made a T-chart before or something like that, then maybe they can calculate the area and put another column on the end. Now again, you don't want to tell them what to do, you want to prompt them to try and work these things out for themselves. So just giving enough of an information or a clue so they can move on without telling them the answer, because you're trying to diagnose what they understand. And at this point, depending on how they go, they could try and find which one's got the biggest area. And if you look at the pattern, they'll see that the biggest area is in fact the square. And then you could ask if they can prove it. And if you're doing this with your Year 11 class or Year 12 class even, which I have done before, then you can even move on to calculus if you want to. Now the purpose of this example is just to show you, as I've already said, from a very simple open-ended prompt at the start, you can find out a whole pile of information about the student's mathematical knowledge, their skills, their attitudes and values about maths, and can they do mathematical practices like problem solving, working systematically, communicating their ideas, looking for patterns and things like that. So I hope that really helps you with that first assignment. Rather than just going with a whole series of test questions, give something open-ended. Because this course is directed for all of junior secondary too, if you're going to go in with a test, you're going to have a whole pile of questions because the kids could be anywhere from, their abilities could be anywhere from Year 4 right up to about Year 10 or 11. Whereas this gives you and you have to have questions for all of those if you're going to do it with a test type closed question. Whereas this gives you one simple task where you can find out a whole range of things. So I hope that's helpful. I hope this is a really good way, even when you start your teaching career, to teach. This is the very question here. I used to do it with my Year 9 kids, and we could work on it for anywhere between 2 and 4 lessons with all these questions we've done before, getting them to investigate stuff. So, just some tips about the teacher's role in these questions, these sort of tasks. First of all, make sure the task is open, but it has a clear purpose and direction. So you can see this one was clearly about rectangles, perimeters, areas, and patterns and things like that. You can have very open-ended questions like Fermi problems. A Fermi problem, the original one I think was how many piano tuners are there in London? But it's something which is very open and doesn't have any clear direction. It's just seeing if the kids can investigate something. Whereas this has a purpose and direction. So I'll have something like that's connected to one or two curriculum areas and has a bit of a sense of purpose and a sense of trajectory towards something. So you can keep extending the kids until they get to the point where they're obviously are stuck and can't go on, and you've reached the limit of their current understanding and confidence and ideas, and from that you can diagnose where they're at. The second tip I'd say to you is know the task. And this is a tip for all of you when you're teaching in your classes. Don't ever give the kids a task you haven't done yourself first. Because first of all, you'll see any problems and issues with it. And secondly, you can see where they're going to get stuck or where they might have ideas or opportunities to teach things. So always do the task yourself first. If nothing else, it'll help you make sure you've got no typos and the task is doable. Sometimes I'll speak from experience. I've given students a task and it's actually impossible. And sometimes I've given them ones where it just was completely inappropriate for what we were doing, but I didn't understand it until I started doing it. So please do the task first. The next point is, once you've got them going on the task, try and give prompts, but don't answer the question for them. You're trying to diagnose what they know and understand. If you give them the answer, then all you know is what you know, which you should already understand. You're trying to find out what they can do and understand. So give them prompts, hints, make sure you note down what they are, but don't tell them the answer. And that'll be a challenge for you right through your teaching career. The next point is be prepared to wait. Give them questions and just let them sit on it for a while they're thinking. Periods of silence are okay. Because what happens as teachers is we give the kids a question, we wait maybe no more than a couple of seconds, and then we jump in straight away. Meanwhile, the student's still thinking about the problem or the issue, and we're already filling the gap. So there's a lot of research that talks about how teachers are very uncomfortable with periods of silence. So if you need to, while you're waiting, just count in your head, of course, and I would wait up to 30 seconds, even a minute, in quiet while the kids are trying to work it out. You might say, are you still thinking about it? Do you have any ideas? But don't jump in with the hint too quickly. So there's some general points about open-ended tasks and ones I hope you can apply for this assignment as well. I hope it's helpful and good luck.